This simulation represents a network moving through three distinct physical states: total rigidity, unstructured chaos, and a synchronized pulsing wave. Classical neuroscience typically attempts to map human consciousness to static anatomical structures or fixed neural wiring diagrams. But an anatomical map only shows the container. It cannot account for the continuous, flowing, subjective experience of time, the sensation of happening. The Brain Kinematics Model suggests a different starting point. Consciousness is a dynamically generated field, appearing and disappearing based on the coordination of physical forces. This field is defined by two primary parameters. The first is form, representing relative rigidity, or the structural stability required to anchor memories. The second is motion, representing relative fluidity, or the transitional capacity that allows sensory activity to stream through the system. Subjective awareness only emerges when the brain successfully coordinates the timing, the interval, between the structural form and active motion. Waking reality is a regulated, mixed texture. To see the world clearly, the brain must be stable enough to be something, yet fluid enough to be happening. The evolutionary path leading to the mammalian brain was a physical engineering effort to balance these two competing forces. To understand how a mind emerges, we must look past the place where it happens and start calculating the kinematic balance of the field itself. To map the subjective experience of mind, we must convert cognitive states into specific, measurable parameters. We start with an axis for rigidity, holding memory patterns. Perpendicular is the axis for fluidity, the volume of new data moving through. The vertical axis is integration, the coupling strength between brain layers. Their interaction yields a specific governing equation for conscious stability. This math reflects a physical reality. Integration acts as a multiplier of awareness, but stability collapses if unbalanced. High rigidity locks the network into obsessive fixation. Conversely, high fluidity creates chaotic fragmentation without a structural anchor. Waking awareness exists only in this central zone, where moderate parameters are coupled by high integration. Human cognition is an ongoing navigational effort to keep the brain's processing state within this specific mathematical volume. This phase space allows us to track the mechanical shift between our waking reality and the fragmented world of dreams. The brain uses memory structures as attractors, points of stability that pull conscious thought along logical, sequential pathways. In dreaming, the brain drops rigidity and spikes fluidity. Weak constraints cause data packets to hop randomly between memory attractors, creating unconstrained narrative jumps. Waking up requires increasing rigidity to bind data to specific networks, creating the stable circuits of logical thought. We can define the subconscious as a threshold state, a region where form and motion are beginning to couple, but the coordination is too weak to generate a full, present-centered image. It is an area of drifting strain organization that influences our awareness from the background without ever reaching the threshold of full integration. Finally, the unconscious is a domain of total decoupling. Data here is stored too rigidly to be mobilized, or is too dispersed to be reportable. Dreaming, waking, and unconsciousness share the same underlying mechanism. They are different tuning regimes of the same node and edge strain flow. If high integration is the key to awareness, evolution had to develop a physical structure capable of sustaining it. In early vertebrates, the brain was dominated by the primitive pallium. Because the pallium was a diffuse, unlayered field of neurons, it could only support localized pockets of awareness, brief, flickering moments of integration. Reptile-like ancestors advanced this by developing simple cortical structures with 1 to 3 layers. This layering provided stronger form and more rigid behavioral patterns, but the brain's motions remained segregated. There was no deep temporal continuity across the system. The breakthrough arrived with the 6-layer neocortex. The deep layers are form-dominant, providing steady output stability to anchor memory. The upper layers are motion-dominant couplers, handling high-velocity sensory data. The critical innovation is interlaminar connectivity, vertical columns binding these two regimes together. By weaving the slow, stable snapshots of the deep layers with the rapid flow of the upper layers, the brain produces tracing frames, the ability to track a single experience through time. This completed framework is known as the vision window, the sustained, continuous sensation of fully existing in the present. Evolution did not merely add more neurons, it bootstrapped reality by inventing vertical lamination to structurally enforce the balance of rigidity and fluidity. The kinematics governing the brain's form and motion may be scale invariant, applying to systems much larger than a biological brain. If consciousness is the result of a structure managing flow, then the same rules of stability and collapse should apply to global civilization. When we zoom out to a global mesh, the topological similarities are striking. Here, the nodes are nations and institutions, their laws providing the globe's rigidity. The strain packages are economic shocks, migration, and digital surges, providing the system's fluidity. Global superpowers act as attractors, pulling trade, ideology, and military focus into their orbit, much like memory attractors pull at a train of thought. We can use the same Say's law to analyze geopolitical stability. A nation with high institutional rigidity but low internal integration cannot effectively distribute the strain of a sudden spike in fluidity. When the incoming pressure exceeds the system's ability to integrate it, the nation enters a state homologous to a fragmented dream. Its borders fail, its institutions fracture, and internal coherence dissolves. Observability also scales. Just as the neocortex integrates data to model the future, highly integrated civilizational networks allow for the modeling and coordination of planetary scale events. Whether we are examining the microscopic layers of a cortex or the shifting borders of empires, the core challenge remains the same. The generation of a stable reality requires the constant, careful coordination of structural form and adaptive flow.